The moon's gravitational pull causes the ocean's water to bulge, resulting in 2 high tides and 2 low tides every 24 hours, with the average tidal range being approximately 0.8 meters. This phenomenon affects approximately 70% of the Earth's surface, which is covered by oceans, and has significant implications for coastal ecosystems, marine life, and human activities such as navigation, fishing, and coastal development. The moon's gravitational pull is responsible for about 68% of the tidal force, while the sun's gravitational pull accounts for about 32%. Here's why that matters. Tides are the periodic rising and falling of the sea level caused by the gravitational interaction between the Earth, the Moon, and the Sun. The Earth's oceans are divided into 2 main categories, the open ocean and the coastal ocean. The open ocean, which covers about 90% of the Earth's surface, has an average depth of approximately 3,700 meters. The coastal ocean, on the other hand, includes bays, estuaries, and continental shelves, and has an average depth of approximately 200 meters. The tidal range, which is the difference between the high and low tide levels, varies greatly depending on the location, with the largest tidal range occurring in the Bay of Fundy, Canada, with an average range of 16.3 meters. The moon's gravitational pull causes the ocean's water to bulge in 2 areas, one on the side of the Earth facing the moon and the other on the opposite side of the Earth. This creates 2 high tides and 2 low tides every 24 hours, as the Earth rotates relative to the moon's position. The sun also has a gravitational effect on the Earth's oceans, although it is much weaker than the moon's. However, when the sun and moon are aligned, their gravitational forces work together to create even higher high tides and lower low tides, known as spring tides. When the sun and moon are at right angles to each other, their forces cancel each other out, resulting in neap tides. Most people assume that tidal patterns are simple and predictable, but in reality, they are complex and influenced by a variety of factors, including the shape of the coastline, the depth of the ocean, and the wind. The Coriolis force, which is caused by the Earth's rotation, also plays a significant role in shaping tidal patterns. In the northern hemisphere, the Coriolis force deflects the tidal bulge to the right, resulting in a clockwise rotation of the tidal current. In the southern hemisphere, the Coriolis force deflects the tidal bulge to the left, resulting in a counterclockwise rotation of the tidal current. The moon's effect on ocean tides has significant implications for coastal ecosystems, marine life, and human activities. For example, the tidal range affects the distribution and abundance of marine species, with some species relying on the tidal cycle to survive. The tidal cycle also influences the formation of coastal landforms, such as beaches, dunes, and estuaries. In addition, the moon's gravitational pull has a significant impact on the Earth's rotation, with the length of a day increasing by approximately 1.78 seconds per century due to the tidal interaction between the Earth and the moon. Tidal energy is a promising source of renewable energy, with the potential to generate approximately 750 gigawatts of electricity globally. The first tidal power plant was built in France in 1966, and since then, several other tidal power plants have been constructed around the world. Tidal energy has several advantages over other forms of renewable energy, including predictability, reliability, and high energy density. However, it also faces significant technical and economic challenges, including the high cost of construction and the potential environmental impacts on marine ecosystems. While the moon is the primary driver of tidal forces, the sun also plays a significant role, although its effect is much weaker. However, when the sun and moon are aligned, their gravitational forces work together to create even higher high tides and lower low tides. Some scientists argue that the sun's effect on tidal forces is underestimated and that it may have a more significant impact on coastal ecosystems and marine life than previously thought. Further research is needed to fully understand the sun's role in shaping tidal patterns and its implications for coastal ecosystems and human activities. In conclusion, the moon's effect on ocean tides is a complex and fascinating phenomenon that has significant implications for coastal ecosystems, marine life, and human activities. The tidal cycle, which is driven by the gravitational interaction between the Earth, the Moon, and the Sun, is a critical component of the Earth's ocean system, and its effects are felt across the globe. Subscribe for more deep dives.